All right, let's get started on our last chapter, which is all about factoring. Factoring is really important. It'll come up in all of your future math classes. It could show up in your science classes as well. It's just kind of one of those things in math that never really goes away. So let's talk about what we mean by factoring. So if you remember, when we have two numbers, let's say 6 times 2, that multiply together to give us something, in this case 12. We call 12 the product, it's what we get from the multiplication. And 6 and 2 are what we call factors. They're things that go into that product. And so what we're doing by factoring is we're going to take the product and then we're going to break it into its factors. So factoring breaks product into factors. So first thing we want to do is we're going to take a look at GCF, which is the greatest common factor. And so we're going to find the GCF, or greatest common factor. So that's just going to be the biggest factor that goes into both of the numbers we're looking at. With numbers first, and then we'll bring variables into this. And then we'll start actually factoring. So this isn't quite factoring yet. One thing that is going to be helpful here, though, is knowing your divisibility rules. So knowing how to tell if 2 goes into a number or 3 goes into a number, because there are some good tricks for those. So there's a divisibility chart. And you know, if you have a calculator, this is easy. We're not supposed to be using calculators in this course. So having this divisibility chart is pretty helpful, and it's on page 432 in the book. That's just kind of helpful. So divisibility rule for 2 is if it's even, then it's divisible by 2. For 3, this is one that a lot of people don't know. If you add up the digits, so if we just look at 432, 4 plus 3 plus 2 gives us 9. Since 9 is divisible by 3, then so is 432. So that's a really nice trick. Same thing works for 9s. So since 9 goes into 9, it also goes into 432. Those are just 2 of the ones that most people don't know that are pretty helpful. All right, so let's go ahead and look at some examples. We're told to find the GCF. So find the greatest common factor. Number 1 here, we're given the numbers 30 and 45. So I'm going to show you guys 2 different methods. Well, I prefer one over the other. It just kind of depends what you like. The first method is using those prime factorization trees that we mentioned before. So I'm going to go ahead and break these down. So 30 can break down into, and it doesn't matter which numbers you pick, 3 and 10. 3 is prime, so we can't break it down anymore. Don't circle it this time, though. We're going to circle it for another reason. 10 breaks into 2 and 5, which are both prime. So we have these numbers at the ends of the branches. I'm going to underline just so we know to focus on those. 45 can break into 5 and 9. 5 is prime. And 9 breaks into 3 times 3. So what we want to do is circle any numbers they have in common, even if they appear twice in both. So this one we have a 3 here and a 3 here, but there's only one 3 on the left, so we're not going to circle that second one. And then we also have a 5 and a 5, and we only care about the numbers on the ends of the branches. And so what we're going to do, now we only need to focus on one of these. We're not going to kind of double up our numbers. Our GCF is 3 times 5, which is 15. And so 15 is the largest number that goes into both 30 and 45. And sometimes when you're looking at these, you should get to the point where you can just kind of look at it and figure out the GCF, depending on the numbers. Ones like these aren't too bad. You can also list out the factors. So like 1 times 30, 2 times 15, 3 times 10, and kind of do it that way, and then see what the largest one is they have in common. That way just takes a little bit longer. The other method, so I guess there's kind of 3, I just don't usually cover that one where you list them out, is something called the cake method. And so I find this one really helpful if you have really big numbers or if you have more than 2. What we're gonna do is we're gonna put the numbers next to each other, so 30 and 45, and then we're gonna draw kind of a flipped around divisibility or division sign. And then what we're gonna do is take out a number we know that goes into both 30 and 45. Assuming we don't know yet that 15 goes in, I'm gonna take out 5 since they end in a 0 and a 5. And then we're gonna divide, so 30 divided by 5 is 6, put it right below. 45 divided by 5 is 9. And then we're gonna add a new layer. So you should have this kind of upside down cake appearing. And then we're gonna repeat. So 6 and 9 have a common factor of 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And now 2 and 3 don't have any common factors, so I can't take anything out other than 1 because 1 goes into every number. So our greatest common factor is what we get from the numbers on the outside. So again, our GCF, just multiplying these together, is 5 times 3, or 15. So whichever method you like better, I'm usually going to stick to cake method. Just for these initial questions, when we start looking at actual polynomials, I'm just going to kind of talk us through it. But if you get stuck, you can always do either the cake method or this first method we went through. So let's go ahead and try another one. Number 2, 30, 20, and 15. So this is one of those ones where, first of all, even though we have 3 numbers, we can still use either of those methods. You just have to do the tree for all 3 of them and see what they all 3 have in common, or do the cake method with 3, which I'll show you here in a second. Or you can kind of look at these and kind of figure out what the GCF is by looking at them if you want. If we were to do the cake method, we would put 30, 20, and 15 in a row, put our first layer there. And now if you notice, we have 3 numbers that end in 0s and 5. So 5 has to go into all 3. 30 divided by 5 is 6. 20 divided by 5 is 4. And 15 divided by 5 is 3. Now, if you look at our next layer, 6 and 4 have a common factor of 2. But 6 and 3 have a common factor of 3, and 4 and 3 don't share any factors. So in order to take something out here, we need to have a common factor with all 3 of them. So since there's nothing to do here, we're going to take the only number that we have on the outside, and our greatest common factor is 5. Let's do one final one. Let's say we had 15 and, let me think of a good one, 22. So if we take a look at this one, the factors of 15, we got 1 and 15, 3 and 5, but none of these numbers go into 22. And so that means that the greatest common factor, we can't just put none. The greatest common factor is 1. So that's the largest number that's going to go into both 15 and 22. So just be careful on those. I know it comes up a couple of times where they give you numbers that don't have any factors in common. Make sure you put 1. All right, and it would be the same thing here if we had 4 numbers. You can still do the cake method with 4 numbers. You just have to make sure that the numbers go into all 4 of them. And I know there is one like that on your homework. All right, so let's take a look at finding GCFs with variables. All right, so let's look at an example here first. Let's say we have x to the 4th, x to the 5th, and x to the 6th. So now this one's a little bit trickier. What we could do is you can still technically use cake method here. We don't generally use it though, but it's totally doable. I'll show you one example with it. We want to know how many x's at most these terms have in common. So if I put x to the 6th, this isn't going to work because this first term only has 4 x's. And so to kind of show you what we want to do here, we can take x to the 6th and write it as x to the 4th times x squared. We can write x to the 5th as x to the 4th times x. And we can write x to the 4th, well, just as x to the 4th. I don't need to break it down anymore. But if you notice, they all have an x to the 4th in them. So that's what our GCF is going to be. It's going to be x to the 4th. And what we're generally looking for here is the lowest exponent. And so this is going to make it really fast when you're finding the GCF. With variables, you're always looking for the lowest exponent because that's the most x's that goes into all 3 of these. So you don't need to find the GCF for the actual numbers, the exponents, unless they have coefficients, and we'll see some like that in a second. Just think GCF of variables, lowest exponent. So let's go ahead and look at some examples. Number 1, we're given 6m to the 4th, 9m squared, and 12m to the 5th. So first thing we're going to do is look at the numbers first. So we're given 6, 9, and 12. The largest number that goes into all 3 of those is 3. And then the most number of m's they all have in common. Well, our lowest exponent here is 2, so it's going to be an m squared. Anything higher than that in this middle term doesn't have more than 2 m's. It only has an m squared. Number 2, 12p to the 5th, 18q to the 5th. So again, let's look at the numbers first. We have 12 and 18, the GCF. And one thing to note, make sure you're finding the GCF, not just a common factor. 2 is a common factor, but it's not the greatest common factor, so that would be incorrect. 6 is our greatest common factor. And what variables do they share? Well, this one has p's, this one has q's, so they don't actually share any variables. So we can't add any variables to the GCF, so we're going to leave it just as 6. And let's go ahead and try 2 more of these. Y to the 4th, z squared. Y to the 6th, z to the 8th. And z to the 9th. All right, so we need to be careful on this one. There's no coefficients, so we don't have to worry about the numbers. If we look at all 3 of the terms, the first 2 terms have y's, but the last one doesn't, so we can't include any y's in the GCF. But we can include z's. We have a z squared, z to the 8th, and z to the 9th. The highest amount that they all have in common is 2, so z squared, and that's also our lowest exponent. And finally, 12p to the 11th, 17q to the 5th. Let's look at our numbers first. We've got 12 and 17. 17 is prime, so these aren't going to have any common factors besides a 1. So I'll leave that off for right now, or we could write it down. P and Q, these are both different variables, so they don't share any variables either. So since they don't have anything in common, the GCF is 1, just like with those numbers that we saw earlier. If they don't have any factors in common, the GCF is 1. All right, now let's get to some actual factoring. So the first thing we're going to be doing is factoring out the GCF. And this is always going to be your first step when you're factoring. So we're going to go through some different factoring methods. And factoring out the GCF is always the first step. It's always going to be the first thing that you do. It kind of, think about it like when you reduce down fractions before you multiply. If you factor out your GCF first, it makes the rest of the factoring a little bit easier. So what we're going to do here, I'll show you one kind of longer worked through example, and then we'll go through some others. Let's say we're given, or we're told to factor 3m plus 12. So sometimes you'll be just told to factor and you have to know what to do. Sometimes you'll be told to factor out the greatest common factor, which means you're going to be doing what we're doing anyway. And since we're factoring out the greatest common factor, first thing we need to know is what that greatest common factor is. So we're looking at all of the terms that we have. So we have a 3m and a 12, just like we were just doing. They don't both have a variable, so we can't take out a variable. But the GCF of 3 and 12 is 3. So now what we're going to do is we're going to put that 3 on the outside of a set of parentheses. Think of this like reverse distributing. So instead of multiplying that 3 in, we're taking it back out. And then we're dividing each term by 3, or divide each term by the GCF. Sometimes I'll actually divide it, sometimes we'll just kind of talk about getting rid of it. So if we look at this first term, we could write it as 3m divided by 3, and if you notice those 3's cancel, so we're left with an m. The other way to think about it is you're getting rid of this 3, you're taking it out, so the only thing we're left with is the m, plus, bring over that sign, 12 divided by 3 is 4. So this is our factored form, and how can we check this? Well, all we have to do is distribute. And that's should be pretty easy to do at this point. 3 times m is 3m, 3 times 4 is 12. Always good just to quickly double check, make sure you didn't make any arithmetic mistakes or miss any terms. Sometimes you'll end up with a 1 in one of these spots, and it's really easy to just kind of drop that off. So I'll show you some examples like that in a second. Let's go ahead and look at some examples. So let's factor out the GCF. Number 1, we're given 4x squared plus 6x. So first thing I'm going to do, I know in some of the homework problems you're given the GCF, so they'll put it out in front for you. So what that could look like is, so for this one, our GCF for 4 and 6 is 2, and this one has 2 x's, this one has 1, so we can take out 1x. You'll also see when you're trying to take stuff out, if I would have picked 2 x's, so an x squared, there's not 2 x's to take out from the second term, so it's just not possible to factor it out. That's another way you can kind of tell if you pick the correct GCF. So if we go ahead and take out a 2, this is something what it'll look like in the first homework problems. They'll give you that the 2x is the GCF, and you'll have to write what goes in this blank. Well, if we go ahead and look at both of these terms, the first one is 4x squared, so 4 divided by 2 is 2. We have an x squared. If we get rid of an x, we're left with a single x, plus 6 divided by 2 is 3. We have 1x, we're getting rid of an x, so there isn't any left. And there we have it. If we double check, 2x times 2x is 4x squared. 2x times 3 is 6x. All right, let's try another one. 10y to the 5th minus 8y to the 4th plus 6y squared. And so let's go ahead and take out the GCF and figure out what it is first. So for 10, 8, and 6, we can take out a 2. And y to the 5th, y to the 4th, y squared. The most we can take out is a y squared. And so now let's divide. 10 divided by 2 is 5. We have 5 y's, get rid of 2, we're left with 3, so y cubed. Minus 8 divided by 2 is 4. We have 4 y's, get rid of 2, we're left with 2. Plus 6 divided by 2 is 3. 2 y's, so there's none left. All right, let's try a third one. We're just running through a bunch of examples here. Let's go ahead and do 8p to the 5th q squared, throw in a couple of variables here, plus 16p to the 6th q cubed, minus 12p to the 4th q to the 7th. So if you're starting to feel pretty comfortable with finding the GCF and factoring it out, this is a really good one to test whether or not you're understanding it, just because it has multiple variables, and this is a pretty standard factor out the GCF question. Let's go ahead and try this one. So we have 8, 16, and 12. The GCF is 4. And now let's look at our p's and q's separately. So our p's, we have p to the 5th, p to the 6th, p to the 4th. So we can take out p to the 4th. And then we have q squared, q cubed, q to the 7th. We can take out a q squared and then see what's left. So our first term, we're focusing on each individual part that they have in common. So 8 and 4, 8 divided by 4 is 2. We have 5 p's, taking out 4 of them, we're left with 1. We have 2 q's, getting rid of 2 q's, so there's no q's left in this first term. So then bring over the plus sign. 16 divided by 4 is 4. How many p's are we going to have left? Well, we have 6, getting rid of 4, we're left with 2. We have 3 q's, getting rid of 2, we're left with 1 q. Done with that term, so minus 12 divided by 4 is 3. We have 4 p's, we're getting rid of 4 p's, so there's no p's left in the last term. So then our q's, we have 7 q's, getting rid of 2 q's, so we're left with 5 q's, or q to the 5th. And always double check your answers, especially ones like these. There's a lot of stuff going on in this one. It's really easy to make mistakes. So always just distribute, make sure those exponents add up to what you have on the outside. I'm sure it's always multiply to what you have for your coefficients. Okay, let's go ahead and try just a couple more of these before we look at factor by grouping. This next one, we're given negative 14a cubed minus 21a squared plus 7a. So there's something slightly different we're going to do with this one. If you notice, we start with a negative here. So it's not as important with these first ones when we're factoring out a GCF. But in general, if it starts with a negative, factor out a negative. And so we'll see why when we get to factor by grouping in a second, why it's important to do that. And I'm not sure if in your homework they're going to have you factor out a negative. Usually they'll specify if they want you to. Otherwise, you can do positive or negative. On tests, I've had people put both, and it's correct either way, unless my math lab specifies. My math lab's a little bit more picky with stuff like that. So I'm going to go ahead and factor out a negative. So what that means is we're still going to find our GCF exactly the same. We have a 14, 21, and 7. So the GCF is 7. I'm just going to make it a negative 7. And then how many A's can we take out? We have 3, 2, and 1. So we can take out a negative 7A. And now this one, you just have to be careful with your signs. Negative 14 divided by negative 7 is a positive 2. We have 3 A's, getting rid of 1, left with an A squared. Negative 21 divided by negative 7 is positive 3 plus 3. A squared, getting rid of an A, we're left with 1A. And then 7 divided by negative 7 is negative 1. And then we have an A, getting rid of an A, so there's no A's left. So we have a 1 here. So just be really careful on those signs when you're factoring out a negative. They should all pretty much flip on the inside because you're taking out a negative from all of them. Okay, let's go ahead and try one more. This last one looks really weird, but it's going to set us up pretty nicely for factor by grouping. So number 5, we're given r times t minus 4 plus 5 times t minus 4. So normally when you see stuff like this, hopefully at this point your instinct is to distribute. However, we're not distributing here because we're factoring. If we were to distribute, that's going in the opposite direction of factoring, and we don't want to do that. That's going to give us more work to do. What we want to do is see what they have in common. And so for this one, it's an entire group. They both have a t minus 4. So what we're going to do, we're going to factor out that t minus 4. So I'm going to put that t minus 4 out in front, factor it out. So if I get rid of that t minus, sorry, one more thing. If we factor something out, we set it in front of another set of parentheses. So we're going to have another set of parentheses here. If I get rid of the t minus 4 from this first term, so this term is this entire thing, we're left with an r plus, get rid of t minus 4 from here, and we're left with 5. Now with this one, it's not going to be as tricky when we get to factoring by grouping in a second. These ones are just a little weird. To check this, you'll want to FOIL this right side out, and then you'll also have to multiply this left side out to make sure that all of your terms match. They might not be in the same order, but they should be the same. Okay, so let's go ahead and use what we just saw here in factor by grouping. So this is our kind of first big method for factoring. Factoring out the GCF is just something you always have to do. Factor by grouping is something we're going to do when we have, I'm actually going to put this in red because this is really important. You're going to want to know when, when to use each type of factoring. So this one is when we have 4 terms. So let's go ahead and take a look at an example. So if we have, we're given 2x squared plus 6x plus 3x plus 9. First thing you want to do is look at this and figure out how many terms you have. We have 1, 2, 3, 4. So we do want to use grouping. And so grouping requires us to group the terms. We're going to group the first 2 terms and the last 2 terms. And I want you to actually leave this plus sign in between. We'll see ones with minus signs, and we're going to change it to plus some minus sign. So just make sure you always have a plus in between, because if you don't, a lot of the times it looks like you're just multiplying, which we're not. We're still adding all these together. We've just grouped them. Now what we're going to do is we're going to factor the GCF. This is another reason why we had to go through the factoring out the GCF first, from each group. And so we're going to have two different GCFs. So if we look at the first group here, 2x squared plus 6x, the GCF of 2 and 6 is 2. The GCF of x squared and x is x. If we're factoring that out, then our first term, 2 divided by 2 is just 1. We don't have to write that for this one because we have an x squared, getting rid of an x, so we're left with x. Plus 6 divided by 2 is 3. We have an x, getting rid of x, so we have no more x's in that term. Close the parentheses, bring down your plus sign, and now we're going to factor out from this group. Greatest common factor of 3 and 9 is 3. And then this first term has an x, this one doesn't, so we can't take out any x's. So now our first term, 3 divided by 3 is 1. We're not taking out any x's, so we do want to keep that x there. Plus 9 divided by 3 is 3. And now one thing you should always notice here is that these two should always match. So two things that could have happened. First one is just a mistake somewhere. Maybe you took out a factor that wasn't the GCF, or you factored it out incorrectly. Or we're going to see some special cases where if they don't match, it means that we can't factor it. So let's go ahead and keep going with this one. Now we're back to the step that we saw in number 5 up here. So this is why we did this. What we're going to do here is factor out this x plus 3 from both. And I'm going to write it just as x plus 3. We don't need that 1x. If we get rid of that from both terms, we're left with this 2x, new set of parentheses, plus 3. And that's it. We have this one factored. So let's go ahead and run through some more examples. Let's get as much practice with this in as possible. Number 1, we're given PQ plus 5Q plus 2P plus 10. So 4 terms, so we know we're grouping. Let's put parentheses around the first 2 terms, leave the plus sign, last 2 terms. And then we'll factor out from each. So the PQ and the 5Q don't share any numbers, but we can take out a Q. So our first term, get rid of the Q, we're left with P, plus get rid of the Q in the last term, and we're left with 5. You can always kind of double check, Q times P, PQ, Q times 5, 5Q. That way you're not having to double check it all at the very end. Bring down the plus sign. These two have a common factor of 2. The first term, get rid of the 2, we're left with P, plus 10 divided by 2 is 5. Do these guys match? They do, so we can go ahead and factor out the P plus 5. If we get rid of it from each of these terms, we're left with a Q plus 2. And one question that always comes up here is, does it matter what order we put these in? So if you remember with multiplication, multiplication is commutative, which means you can flip this around. Just make sure that your terms are still the same. So we still have to have Q plus 2 and then we still need a p plus 5, but it can be flipped around. That's perfectly fine. Let's try another. Let's go ahead and do 2xy plus 3y plus 2x plus 3. So first thing here, let's go ahead and group our first two terms, leave the plus sign, last two terms, and then we'll factor out from each group. So first group here, we don't have any common factors for the 2 and 3. They don't both have an x, but they do both have a y. And so if we get rid of the y, we're left with 2x plus, get rid of the y, we're left with 3, plus 2 and 3 don't share any common factors besides 1, and they don't both have an x. So what do we put in front if they don't share any factors? Well, they still share a factor of 1. So you do want to make sure you actually put that 1 out in front. It's going to be really important for our last step in a second. If we divide by 1, it doesn't change the term. So we can go ahead and just bring down this 2x plus 3. And if you think about checking that, 1 times 2x is 2x, 1 times 3 is 3. And so now if we go ahead and factor out this 2x plus 3 from both, that's gone. We're left with a y plus 1. So this is where one of those really common mistakes happens. If you forget to put this 1 here, you'll just have 2x plus 3 times y, because you won't have anything here. If we do that, then we have 2x times y, which is 2xy, and 3 times y, which is 3y, but then we're missing these last two terms completely. So make sure that you put that 1 there. It's really important. That's another reason why checking your answers is important. It's really easy to just kind of look over that 1. All right, let's try a third one here. Let's go ahead and do x cubed plus 3x squared minus 5x minus 15. All right, so this is one where you have to be a little bit more careful with your grouping. And so what we're gonna do is we're still gonna group these first two terms. They're nice and positive. Let me change this to red. One thing we have to be careful with though is we can't leave this minus sign in between like this, because this minus sign is just for this 5x. If we put parentheses like this, think of it like distributing. That would mean that we're also subtracting negative 15, but we don't want to do that because we want a minus 15. We don't want a plus 15. So what I'm going to do here, I'm going to spread this out a little bit actually to give myself a little bit more space. So minus 5x minus 15. I'm going to throw in our parentheses in 1 second. I'm going to change this to plus negative 5x. That way we have this plus sign in the front that we like to have. Now if I throw in our parentheses, we have a plus sign in the middle, and then our two groups here, and the only negative thing here is the 5x. Or the only thing that that negative is going to, because the 15 is still negative like we want. Now we can go ahead and factor out our GCF. This is another one we have to be careful with. First two terms, though, still not a problem. We have no common coefficients, but we can take out an x squared. Take out 2 x's, we're left with 1x, plus, take out these 2 x's, we're left with 3, so x plus 3, plus, now this is one where you have to be careful. If we were to factor out, so the GCF here is 5, if we were to factor out a positive 5, and don't write this step down quite yet, Negative 5 divided by 5 is negative 1. We're left with an x. Negative 15 divided by 5 is negative 3. And so what you'll notice is that these guys here don't completely match. They should actually be complete opposites. X's are opposites, the 3's are opposites. So what we want to do, I'm going to get rid of that. Our GCF is still 5, but this is what I was talking about, where if it starts with a negative, take out a negative. So let's go ahead and factor out a negative 5. And so I'm going to change this to a minus 5. Plus negative 5 just looks kind of ugly. We always like to put minus signs instead. Now, negative 5 divided by negative 5 is a positive 1, left with an x. Negative 15 divided by negative 5 is a positive 3. Now they match, so we can go ahead and factor out that x plus 3. And we're left with x squared minus 5. So again, be really careful with those negatives, change it to a plus and negative. It only matters on this third term here, this last one doesn't matter. And then make sure when you start with a negative, take out a negative. All right, let's go ahead and do one more. Do it over here so we have plenty of room. This one here, we're given 9mn minus 4 plus 12m minus 3n. So let's go ahead and look at this one. Let's go ahead and start grouping. Group the first two terms, the last two terms, leave the plus sign in the middle. The greatest common factor of 9 and 4 is 1, and they don't share any variables. So we can't take anything out of these first two terms. And anytime you can't factor anything out, that means that this one cannot be factored as it is. So what we want to do, since we can't take anything out, is rearrange the terms. And so if we just flipped these first two, that's not going to help us because they're still going to be grouped together. Same thing with these last two. If we flipped those, these are still grouped together. So what we want to do is flip the two middle terms. So we're going to keep this 9mn and then plus 12m minus 4 minus 3n. And so now if we can't factor here, if we can't take anything out, this is where we would say that it's not factorable. But we want to go ahead and try first. So let's go ahead and try grouping our first two terms and our last two terms. We have a minus sign, so I'm going to change it to plus and negative. Throw in our parentheses. It's a really small negative, but it's there. And now let's try factoring out. 9 and 12 have a common factor of 3. So since we're starting to factor here, we should be good to factor. We can also take out an m. So our first term, 9 divided by 3 is 3. We can get rid of an m. We're left with n. Plus 12 divided by 3 is 4. We're getting rid of this m, so that's all that's left there. And now, if we go ahead and factor out from here, 4 and 3 don't have a common factor, and they don't share any variables. So it's fine if this happens in the second group. If it happens in the first group, it kind of stops us from being able to factor. So always rearrange if that happens with the first group. With the second group, you want to factor out a 1. And in this case, we want to factor out a negative 1 because we start with a negative. So negative 4 divided by negative 1 is positive 4. Negative 3 divided by negative 1 is positive 3. We still have that n. And now these look different, but because they're addition, we can add in any order. So 3n plus 4 and 4 plus 3n are actually exactly the same. So I could go ahead and rewrite those if I wanted to as both 3m plus 4, or you can just go, sorry, 3m, or you can go straight to the last step. I did it on both of them. Or you can go straight to the last step and just factor it out. It's up to you. But now we can factor out 3n plus 4. And what are we left with? 3m minus 1. And one thing we didn't talk about completely as far as checking these, how would we check these ones? Well, we just want to FOIL it out. And don't combine like terms because all of these have 4 terms in them. If you combine, you might have to combine in the original problem as well. But you should have all the same terms. They might be in a different order, but you should have all of the same terms with same numbers and exponents on the variables. All right, so that's it for 6.1. That one's a little bit longer because we went through 2 different kinds of factoring. Next, we're going to take a look at factoring trinomials, so 3 terms. And we're going to look at that for a couple of sections because there's some different ways of doing that. So that's what we'll take a look at in 6.2.